Our recent study of the Schmidt trigger, which had two outputs, either a high output or a low output, leads us naturally into the discussion of digital devices. And digital devices also have only two outputs. And so to develop that, let's consider this device here. It has an input and an output. Often the output, or the negative side here, is just ground. So you can just consider one input and one output, a voltage at that source. And imagine that this device has this transfer characteristic in that you put this voltage in, so this voltage goes along the x-axis, and the voltage that comes out is on the y-axis, that's over here. So this device has two characteristic voltages, a ground voltage, or 0 coming out, and 5 volts as the high side. So it has a high voltage and a low voltage. We'll call that those things. And the output also has those characteristic voltages. So that when, and in this case, when we put in the low voltage on the input, in the input we put low, we get out a high voltage. And when we put in a high voltage, we get out a low voltage. So if we just restrict ourselves to 0 and 5 volts, we call them low and high, or sometimes just 0 and 1. And now if we just restrict ourselves to those and try to avoid this middle region, then we're talking about digital electronics. We enter the digital domain. And in fact, this device here with this transfer characteristic is called a NOT gate, in that it turns a positive signal into a true signal into a false signal. So something that's not true is false. There are a bunch of other devices, many of which have two inputs, an AND gate, an OR gate. This one puts an output if both of the inputs are high, it gives a high output. An OR gate puts out high if either or of the two inputs are high. And then you can take the inverse of that, not AND, the little circle there means not and not OR, otherwise NAND and NOR. So the important thing to understand with digital devices is that they're tolerant to noise, and this is one of the great uses of digital devices. So what we do is we define two output levels that are not quite 0 and 5, just a little bit below 5, a little bit above 0, which is good enough. And we say that for the output, everything above V out high is considered to be high, and everything below V out low is considered to be low. And that means that anything in the middle, we don't know what to do with. And that's good for the output. It's nice to make the input more lenient so that anything below V in low in this NOT circuit will produce an output that's very close to V out high. And notice that there's a lot more room here than there is here. And likewise, there's a V in high above which the output will be V out low. And so here, the only undefined inputs are in this small region. And as long as we're in this region or that region with this transfer characteristic, we're guaranteed to get an output that's in one of the two defined regions. Now, digital electronics has a whole set of families of these, of which we're primarily going to be considering TTL, which is transistor logic, and CMOS, or complementary MOSFET. This, in fact, is the transfer characteristic for a CMOS NOT chip. And here's the values for CMOS. The outputs of low and high are very close, so only 0.05 volts, and the inputs are very close to the center. Whereas for TTL, everything's shifted down a little bit. The out high just has to be above 2.5, in high above 2, output low just 0.4 volts. Notice that the amount of current going out is much higher for a TTL than for CMOS, and we'll see why that is by the end of the course. And what that means is, oh, well, actually, it's when the output is low, it will draw a lot of current is the real problem. That means that you can only connect one digital logic of TTL to 10 things because all those currents will draw the inputs low, whereas CMOS can be much greater than 50 because of the low currents involved. And here's sort of a diagram of the various heights of those things. So CMOS here with its small output voltages, TTL in these two. There's not really much difference between TTL CMOS and TTL. This is just when you connect the two.